In this part of section 5.3, we're going to actually take the fundamental theorem of calculus and apply it to some problems. In our first example, we're going to let f of t be a function that represents the population of a bacteria, and at t equals 0, there's 4,000 bacteria. After t hours, the population is growing at an instantaneous rate of 2 to the t,000 of bacteria per hour. We need to estimate the increase in bacteria during the first hour and the total number of bacteria at the end of t equals 1. So, remembering that, we have our units as thousands of bacteria per hour. If we integrate, that would give us bacteria. So our rate of change is 2 to the t. And I want to integrate from 0 to 1 because I want it in the first hour. So if I go ahead and use the calculator to integrate this, and you may want to pause the video at this point and make sure you can enter this into the calculator correctly and get your answer. When you get done, you should get an answer of 1 over the natural log of 2, which is 1.443. Now, going back and recalling that our units are thousands of bacteria, that would actually be 1,443 bacteria. Now, that number is going to represent our increase in bacteria during that hour. So if I take our increase and add that to our beginning bacteria total, we now know that at the end of the first hour, we have 5,443 bacteria. So we've actually answered both parts to the question. In our second example, we're going to look at that fundamental theorem of calculus, but this time we're going to look at it graphically. So let's say we have two cars, and we'll go ahead and label our pictures as car A and car B, that are starting from rest at a traffic light, and then they begin to accelerate. I want to know which car is ahead after 0.25 minutes, not seconds, and after 1.5 minutes. So let's look at the graph. At 0.25 minutes, we would be here, and we can see that car A has traveled a farther distance. Remember that if this is velocity and time, then the definite integral, which would be the area, would give me my displacement. So since car A has more area under the graph, it would be farther out. So for car A has traveled the farthest. Now if I look out at 1.5 seconds, we would be here. And keeping in mind again that my integral from 0 out to 1.5 would include my area, it's obvious that in this case now, travel B, or car B, has a bigger area under its curve, so it would have traveled the farthest. So at the end of 1.5 minutes, then car B would be ahead.